Good morning, student. Today our topic is isomerism in alcohol. Isomerism in alcohol. We know about isomerism. Isomerism, a process. First, we discuss about isomer. Isomers, a type of molecular formula. A type of molecular formula which have two or more than two different structure or the spatial arrangement of the molecule is called isomer, and this process is called isomerism. For example, we have a general formula C4H10. C4H10. We present in this molecular formula in two types: CH3, CH2, CH2 and CH3, 4 carbon with 10 hydrogen, and another type CH3, CH, CH3 and CH3. Both of examples have same molecular formula C4H10, but this is the butane, and this called is 2-methyl 2-methyl propane. So we can see the molecular formula C4H10 have two isomer. First is the normal butane and second is the 2-methyl propane. So this process is called isomerism. The alcohol present mainly four type of isomerism. First is the chain isomerism of alcohol. Alcohol represent four types of isomerism. First is the chain isomerism. Second is the position isomerism. Position isomerism. Third one is the optical isomerism. Optical isomerism. And fourth last is the functional group isomerism. Functional group isomerism. Chain isomerism, a type of isomerism in which the elongation of chain or length of chain is changed. Examples are called chain isomers, and process is called or phenomenon is called chain isomerism. And this example is also the example of chain isomerism, because here the chain elongation or length of principal chain is changed 1, 2, 3, and here 1, 2, 3 and 4. First example have 4 carbon and second example have 3 carbon in the principal chain, so it is called chain isomerism. And similar in alcohol, if we contain example of C4H9 and OH. C4H9 and OH. This can be present as CH3, CH2, CH2, CH2 and OH. And the second type of this example is CH3, CH3, CH, CH2, sorry, CH3, C, CH3 and CH3 and OH. Here 1, 2, 3 and 4 carbon. This is the butane 1-all, and this is the 1, 2 and 3, 2-methyl 2-methyl propane 2-ol. This is the propane and this is the butane. Butane 1-ol and propane 2-ol. So in these examples, elongation of chain or length of principal chain is changed. So it is called chain isomer, and this is the example of chain isomer. Second is the position isomer. In position isomer, position of position of position of functional group is changed. Means no change in the elongation of chain, but change in position of functional group. We can take again this example or other. We have another example also. First we discuss about the another example. We have CH3, CH2, CH2 and OH. This is the 1, 2 and 3. IUPAC name is 3 carbon pro single bond in and 1 and all. Propane 1-ol. And if we change the position of functional group, means OH group, from first carbon to second carbon, it became CH3, CH, CH3 and OH, and name of this compound is suggested as 3 carbon pro single bond in, and the position of functional group is 2. So it is called propane 2-ol. And first is the propane 1-ol and second is the propane 2-ol. But both of molecules or both of compounds are propanol. But first is the 1-ol and is the second one. So it is clear change in position of functional group. So it is the example of position isomerism. And in this example, I also we can define the position isomerism. We take the example of butanol 1, CH3, CH2, CH2, CH2 and OH. This is the butane 1-ol. And if we change the position of OH from first to second carbon, we have the example CH3, CH2, CH, CH3 and OH 1, 2, 3 and 4. This is the butane 2-ol. 1, 2, 3 and 4. Butane 2-ol. So first is the butane 1-ol and second is the butane 2-ol. So this example also contains the position isomerism. And now third is the optical isomerism. Optical isomerism is related with stereoisomerism. This is related with stereoisomerism. And here a simple example of the stereoisomerism can be given as a type of compound in which at least one chiral carbon is represented as optical isomerism. And the chiral carbon is defined before in previous class, a type of carbon in which all 4 valency of the carbon is bonded with 4 different type of groups is called chiral carbon. Means organic compound in which at least one such type of carbon which carbon have all the 4 valencies are bonded with 4 different groups like this: H, C, OH, CH3 and C2H5. In this example, this carbon contains 4 single bond 1, 2, 3 and 4, but all 4 valencies have 4 different groups. So this is called chiral carbon, and this compound can be represent the optical isomerism. And last, the functional group isomerism. Functional group isomerism. Most important group or most important isomerism of alcohol. Alcohol, we have three compound: ROH, sorry, HOH, ROH, and ROR. This is water, this is alcohol, and this is ether. I tell you, alcohol represent the functional group isomerism with ether. And first, what the functional group isomerism? A isomerism in which the change of functional group takes place. An isomerism in which change of functional group each takes place is called functional group isomerism. Like this, we have CH3, CH2, and OH. This is simple compound ethyl alcohol. Ethyl alcohol. Ethyl alcohol. And if we change this example from, we move this CH3 from this side, means back side, it becomes CH3O and CH3, and this is the O alkoxy group, and this is called ether, and name is suggested dimethyl ether. This is the alcohol, and this is the ether. So these two examples are the examples of functional group isomerism, because these compounds contain two different functional group. First is contain alcohol group, and second is contain ether as a functional group. And the another example of this type is we have CH3, CH2, 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 and OH. This is the butanol. Butanol. And this can be arranged as CH3, CH2, CH2O, and CH3. This is methoxy propane, or called as methyl propyl ether. Methyl propyl ether. So these four types of isomerism which can be represented by the alcohol. Thank you.